Okay, in this video I'm going to continue on with exercise 6C of the book Fundamental Applied Mathematics. We're on page 164 and the question is number 3. This reads, a body of mass m is moved from a point P on the Earth's surface to a point Q where its distance from the Earth's surface equals the radius of the Earth. Find the ratio of Fp to Fq and the gravitational forces at P and Q. So let's first of all sketch what's going on. If I draw this here, this 2D circle to represent the spherical shape of the Earth. And we're told initially that it's moved from a point P on the Earth's surface to a point Q, alright, where the distance from the Earth's surface equals the radius of the Earth. So basically this is equal to the radius of the Earth, and well, clearly this is also equal to the radius of the Earth. Now I know I didn't draw those proportional. So what we can say as follows is that the distance, we'll say we'll call that R, from the Earth's center to Q is equal to twice the radius of the Earth. And the distance from the Earth's surface to P is equal to the radius of the Earth. Now you got to remember, of course, that for Newton's law of gravitation, it's just going to write it that it's from the center of the bodies. So usually bodies in space are spherical due to I think it's the Coulombic attraction, and also this particular one here. But anyway, we're looking at everything from the center of it. Okay, so let's have a look here, and we see that if we apply Newton's law of gravitation, we're going to get that 6.6 times 10 to the minus 11 times the mass of the Earth, which we're given as 6 times 10 to the 24, times the mass of the particle, I'm just going to say it's m, we don't know what it is, divided by the radius to be squared. So let's see something now. Okay, so we're going to get first of all, the gravitational force at Q. So that's going to be twice the radius of the Earth. So it's 2 times the radius of the Earth is 6.4 times 10 to the 6, so it's 6.4 times 10 to the 6, all to be squared. So we're going to find the force at Q is equal to, pull out the calculator once more, so say 6.6 times 10 to the minus 11, multiply that by 6 times 10 to the 24, divide that by 2 times 6.4 times 10 to the 6 squared. We're going to get a force of 2.41 times the mass of the particle. Okay, so let's do the same thing for the force at P. This time the only thing that will change is the radius, okay, and we're taking out this factor of 2 here. So F at P is going to be equal to 6.6 times 10 to the minus 11, multiplied by 6 times 10 to the 24, divided by 6.4 times 10 to the 6, close your brackets, square it, get an answer of 9.6 m. That's the force. So we're asked to find the ratio Fp is to Fr. So that's going to be 9.6 is to 2.41, or we could say it's 9.6 divided by 2.41. 1 is to 4 essentially, like that. Now 1 is to 4. Does that make physical sense? Does it make physical sense, you need to ask yourself. Alright, so just bear with me one moment and I'll clear out this. I said already, well I said in a previous video, that the force due to the gravitational force between two bodies falls off at 1 over r squared. So that if you're at position x and your gravitational force is y, if you went to position of 2x, then your gravitational force is not y over 2, but rather y over 4. Because you've doubled the that's supposed to be 4, you've doubled the radius, but that means you've quadrupled, or you've dropped it by a factor of 4, if that makes any sense. Okay, so that's exactly what we've done here. We've moved from a position, and we had a certain force, to twice that position, so we should have a quarter of the force. And that's what we have here. We have 1 is to 4. Or you could say 1 is to be 4:1 or 1:25. Alright, thanks for watching. Please pass it on to your friends and subscribe to my channel.